All right, we're going to start off our linear functions unit with our slope. All right, you've done slope 1,000 times probably. All right, but you've probably forgotten it also. So we're going to start with slope from a table. So if I have a table of numbers, we got to figure out how to find the slope of that data. All right. First of all, you need to kind of make sure it's a linear set of data. And the way you can do that is as long as it's a constant change down the columns, it's a linear set of data. Like it's subtracting 2 on every y, it's adding 1 on every x. As long as it's a constant change down the list, it's a linear set of data that will have a slope. All right, so you find slope in a table by finding m, which always stands for slope, first of all. Anytime you see m in any kind of problem like this, it's talking about slope. All right, and you do what we call, you find the change in y and divide it by the change in x. You see these little symbols right here. That's a Greek alphabet symbol for delta. And anytime you see delta as you go on in life to physics or whatever you do, delta means the change. Okay, so the change in the x's over the change in the y's. So let's figure out this first table here. I want my change in y. Okay, so what is my y doing from one y to the next y? It's subtracting 2. Okay, from one y to the next, it's subtracting 2. What's my x doing from one x to the next x? It's adding 1. So to find my slope here, all I need to do is put that change in y, which is negative 2, over my change in x, which is a positive 1. So I can simplify that. You can probably leave it as that, or I can simplify it so the slope is just what? Negative 2. Okay? Y is always on top in slope. Why is that? Say it again. Rise over run is how you find slope. And your rise is figured out by your y values. That's up and down. That's your rise. Y is your run, side to side. That's going to be on the bottom. Okay? Let's do this next one. What is our change in our y? It's adding 3. What's our change in our x? Adding 2. So I have change in y over change in x. And that's your slope, 3 over 2. And do the next two for me. All right, so on this first one here, change in it at y was plus 6, change in y was 3, 6 over 3 is just 2. On the next one, the change in y was adding 1, the change in x was subtracting 2, negative 1/2. Any questions there? Nothing major, nothing earth-shattering. I think we're all good there. Scroll down. Now, if we have slope from an equation, okay, this is an equation you've seen before. All right, y equals mx plus b. This is called a slope intercept form. Why do you think it's called the slope intercept form? Why? What are the two things you think this equation gives you? It's literally in the name of the form. This equation gives you the, guys, slope intercept form. There's two words there. So what do you think this equation gives you? It gives you the slope of the line, and it gives you the what intercept? Y-intercept. Okay? So this equation gives you the slope of the line and the y-intercept. That's why it's so aptly named slope-intercept form. Okay? It gives you the slope of the line, which is always m, and it gives you the y-intercept, which is always the b right there. So these are easy, easy, easy. What is the slope of this line given that equation? What's m? What's the m value? That's it. Last year I had so many people screw this up. The first way you can screw this up is put the x. The x is not the slope. A slope is just a number. It's the number in front of the x. That's all it is. So my number 2 there, that's a problem, right? Because my y isn't by itself. How can I get my y by itself? If I minus 3, that's not going to do anything. I have to split up the 3 and the y. So I have to divide by 3. You did. Somebody else said subtract, so I had to deal with that. Okay? So you subtract, you divide both sides by 3, I have y equals 4x. What's the number in front of the x? So what's the slope? 4. Okay? This next one, again, I have to get the y by itself because that's what the equation is. So what do I have to move? I have to move my x. How do I move my x? It's being added, so how do I move it? Subtract. Subtract x from both sides. Now, the form is kind of flipped around there, but it shouldn't matter. The number in front of the x is still your slope, and the other number is still your y-intercept. So what is the number in front of my x in that? No. What number is I'm not talking about what number is also in the problem somewhere in front of the x. I'm saying what number is directly in front of the x. What's the coefficient of the x? What kind of one? Negative 1. Because in front of this, there's a 1. I know some of y'all might say it, but I heard a lot more 3s. Okay? Negative 1. You can rewrite that as y equals negative x plus 3. To me, that just seems like more work. All right? But it's the same thing. All right? I still have a negative x, I still have a positive 3. How about number 4 here? Just a 2? Negative 2. We got to start looking at those signs as more than just subtraction and also a negative sign. Okay? That's the easiest one in my eyes. There's not much math except for getting the y by itself. All you got to do is figure out what is the coefficient directly in front of the x, and that is your m value. Okay? Can we do that? Let's find slope from a description. Slope is nothing but the rate. Give me some rates that you deal with on a daily basis. It's like blank per blank is a rate. You don't do it yet, but eventually you're going to drive to school. What rate do you have to deal with when you drive to school? Miles per hour. That's a rate. Okay? That's a rate. All right? When you fill up with gas, it's what? No, but price is what I'm more worried about. What is it? Dollars per gallon. That's a rate. Okay? If you're, those of you that play football, if you're a running back, what might you figure out to see how good you're doing as a running back? Yards per carry, or yards per reception if you're a receiver, yards per throw if you're a quarterback. That was me. Okay, yards per game for a team. Okay, those are all rates. Usually the word per in between tells you it's going to be a rate. Okay, so Dominic, spelled with a K, can do 20 push-ups in 1 minute. So what is the rate of push-ups he's doing? 20 push-ups in 1 minute. Okay? That's the slope. All right, 20 over 1. If we were to graph that, it would be a very steep line of 20 over 1. Jada can do 45 push-ups in 3 minutes. 45 push-ups in 3 minutes. I could simplify that. Both of those can be divided by 3, right? So it would be what? 15 push-ups in 1 minute. What if I told you to find the slope if there's another rate that is very important? It basically decides if you're living or not. Heart rate. Okay? Your heart rate. How's that measured in? Beats per minute. Okay? Your heart rate's measured in beats per minute. That's a pretty important one. All right? If that gets down to 0, you're probably not doing very well. All right? Or the other way. If that gets up to like 200 or 300, you're probably not doing very well. All right? Moving on from our descriptions. Okay, we're going to go to the back. Find slope from 2 points on a line. Okay? From 2 points on a line. If I give you 2 points on a line, okay, you can find the slope. Here's the deal. This is really no different than what we just did on the top of the front of the page. This is really still the difference in y's over the difference in x. Okay? This is still difference in y over difference in x. Okay? So down here, I'm going to write it out and do it. So first of all, you have to understand here, the first number is x, the second number is y. So people always get this backwards. So I have to do my second y, which that would be right here, minus the first y. So y2 minus y1. So 11 minus 7 over my x2, subtract from my x1. 5 minus 3. 11 minus 7 is 5 minus 3 is, that can simplify to 2. Okay? But you need to do y2 on top minus y1, x2 on bottom minus x1. So, what is my second y value on number 2? 3. What's my first y value? 2. Second x value? Minus negative 5. Here's where we got to remember our subtraction of negatives rules. On the well, no. I have minus a negative. Well, first of all, 3 minus 2 on top is 1. On the bottom, we have negative 8 minus a negative. That minus a negative back to back, I need to change it to a plus sign. So I have negative 8 plus 5, which as Jalen back there said is negative 3, because 8's bigger, it's negative, so it's negative 3. So it's negative 1/3. Here's the deal. Let me be honest with you for a second. What if you were to accidentally put these numbers minus these numbers? Would you get the same thing? 2 minus 3, right? Negative 5 minus negative 8. That'd be negative 1/3. Because here's the deal. They didn't just like pick out 2 special ordered pairs. They could literally give you the same problem but flip the ordered pairs and you'd get the same slope. Okay? That doesn't change anything. As long as you do this ordered pair subtracted from this ordered pair, you'll be fine. Okay? But the easiest way to remember it is always to do y2 minus y1, x2 minus x1. Okay? Do the last one real quick. Won't take you 2 minutes. Do the last one. Yeah, so we have on this one, go away. Go away. y2 is over here, y1 is right here. So I have 8 minus negative 4 over negative 2 minus 6. Minus a negative becomes plus. 12 over negative 8. I can divide both those by 4, correct? So I have negative 3 over 2. Any questions? Last one here. I can finally find slope with a graph. Now, every single one of these is, M is rise over run. M is slope. They're all the same thing. It's just giving you different ways to look at it, okay? As long as you know that the top is the amount that it's going up or down, the bottom is the amount of going side to side, it's always going to be the same. Okay? Top is rise, bottom is run. So down here on this first one, here's what I want to do. I want to find 2 points where the graph is perfectly intersecting with a grid. Okay? And I want to figure out how far I'm going. I'm going down 1. Now here's the deal. If I'm going down 1, that is a negative 1. Correct? If you're going down, it's negative. If I'm going to the right 1, that is a positive 1. Negative 1 over 1 will just be negative 1. Now let me show you this. Here's what I'd like to do. Because it's rise over run, I always take care of the rise first. That way I never confuse. If you can do it without confusing yourself, all power to you. But because it's rise over run, I always try to go up or down first and put that on the top of the fraction. That way it'll confuse me less. Does that make sense? I take care of the rise first since it's rise over run. Now, if I picked out those 2 points, 0, 0, and 1, negative 1, it would be the same thing. It would be negative 1 minus 0, which is negative 1, 1 minus 0, which is 1, to get negative 1. I'm doing the same thing. I'm just doing it visually instead of having to actually subtract it. Okay? Let's do this next one. It looks like I have a point right here, right? At negative 1 up 2. There's a point where it's perfect, right? Where's another point where it perfectly intersects? 2, 3 up here. Right? Now what I'm going to do is try to connect those dots. So I'm going up 1, and I'm going right 1, 2, 3. I'm counting the number of jumps it takes. So I went up, which is a positive thing, and I went right, which is a positive thing. So this is going to have a positive slope of 1/3. So look at those 2 graphs. What can you tell just by the picture of a graph if it's a positive or negative slope? Just by the picture of the graph, how do you tell if it's a positive or negative slope? If it's going up to the right, if it's rising up to the right, it is a positive slope. If it's going down to the right, it's negative. That's always going to be true. So you can check your work at the very beginning. And if you know, hey, it's going up as I look at it, as I read left to right, it's going up. It better be a positive slope. Oh, it's going down as I look at it, it's going to be a negative slope. So this last one here. I always try to look, it looks like 0, 0 is a perfect spot, right? Where's another one? Negative 1, 4. You could have also chose 1, negative 4, right? There's one down here. Either way is okay. So I go up how many? Up 4. 1 left, so what does that represent with a number? Negative 1. I'm going to the negative direction, which is left. Negative 4. If you went down, that means you're going down 4, which is negative 4. You're going right 1, which is a positive 1, which is still negative 4. Yeah, it doesn't matter.